Hello and welcome back to Munro Live. We are continuing our wall charger teardowns. And we have with us today Dave and Julian. Dave is an electrical engineer. Julian is a mechanical engineer. I'm a chemical person, battery. He knows what he's talking about when he gets into nitty gritty. We are relaying information that he tells us as best we can. So let's dive in.
Yeah. So we'll start off like we typically do, going through the overall construction build process. We'll have some B-roll of the actual teardown where needed. But just overall to start, this is more or less what's out of the box. We have our charge cable, which comes pre-installed to the unit. Injection molded housing, relatively small, with, again, as is typical outside of the Tesla wall connector, a separate unit for wall mounting and hanging your cable. One thing of note, though, is that this is a single injection molded piece, whereas with a few of the others it was two pieces that were either fastened or snapped together. So moving into the main housing, as is standard across all of these chargers, there is a light indicator on the front in the form of this ring, which if we remove this outer polycarbonate frame, we can see that the fasteners to remove the lid are accessed. There's only 4 of them here. This is another polycarbonate piece with a Wallbox decal sticker placed over the top. We remove that, and actually on the inside, as removed, this circuit board was located inside, fastened to the plate itself with another 4 fasteners. So this in itself was unique. We'll have Dave walk us through some of the eye-catching and unique features of these circuit boards a little bit later on. However, on the back side of the board, one thing that I am confident speaking to is in terms of the light emitted through the outer face of the housing itself. You can see around the perimeter there are a series of LEDs that will do essentially what in the Tesla connector we had the cable off of the PCB running up to emit along that line along the center of the face. So that's all for the board for now. We'll get back to that a bit later. Inside, you can see that connecting between the two, we have a cable here that snaps into a connector on either of the PCBs, and removing that then leaves us with our high voltage circuit board. That, again, an additional 4 fasteners, and then that pops out, and then you're left with effectively just the polycarbonate injection molded base for the housing and an injection molded plate for wall mounting. This in itself is, again, something closer to what we'd like to see. Full integration of the housing would have been nice, but again, this necessitates that you don't need to open the unit to mount it. But this is also better than some of the stamped steel mounting brackets that we've seen with some of the others, like the Grizzly or the Top Dog. So, Antonio, as far as the overall buildup, have we missed anything so far? Any comments from you?
Would you call the housing mounting bracket typical or atypical?
I would say it's atypical as far as the others that we've seen. Okay. Due to them being metallic. So, yeah, atypical, but better.
Yes. The cable itself, the rubber insulation on it is a bit thicker, and there's a 3 leads coming in. The connecting press fittings here are not the best quality. These are probably lower end on that. We prefer the ring connections or hook loop connections. Those are much more effective and less prone to quality issues. And there is a small data cable as well. But now we're going to start getting into the electronics, where Dave will really carry our weight for this one. So we have a high voltage board and a low voltage board. Let's start with the high voltage board. Most of these components we're familiar with from some of the other teardowns. Dave, can you explain what we're going to see with some of these typical features? These 3 varistors were a common feature we saw on some of the other boards. Correct. What are these doing?
They're basically looking for voltage spikes. They're like a variable resistor, and if the voltage spikes, they'll short internally, and then it'll return to a state of non-conduction once that's done. Looking over here, we've got some capacitance and a couple inductors. We have a common mode coil here, which is prior to entering into this DC-DC converter, AC-DC converter. It's taking the 110 volt main AC and converting it to 10 volt or 12 volts for the controls on the board, and especially for this board over here. So it's like your first stage of getting a DC power supply to operate all the electronics.
Right, because they can't operate the voltage just coming in from the wall.
No, there's usually some type of rectification. In this case, they've actually bought a formal AC-DC converter instead of doing a discrete buildup on the board. So probably a good way to do things. Takes a lot of the design effort away and ensures that it's going to work properly. Then, go ahead.
Some of the things we saw on the other ones were when the cables were coming in, they had a lot of sensors and ferrites on them. So what is doing that on this board where we're not seeing that in the cabling here?
Okay, great question. This right here is a differential current sensor, and this one here is a Hall effect current sensor, the smaller one. So what this one is looking for is it's looking for current differences, leakage currents. It's really there so that they can ensure that if there is an issue, they can detect it and shut the system down. So that is its primary job, whereas this one is looking at just current in general, how much current is moving through the system.
Okay. Anything special on the back?
A lot of support for just what we were just talking about, and your typical componentry to effectively work with the other parts.
We also noticed there was no conformal coating on this, so that made your job a little easier for identifying these parts, right?
Well, it looks almost like there could be some type of conformal here.
Yeah, I'm seeing fingerprints and stuff.
I'm looking at the shine, but there are some newer ones that are thin. There's nano coating, stuff like that are not so readily detectable. So there could be a protectant down here that's not easy to identify. The traditional ones are easy to identify,
right,
but some of these newer ones are not.
Is one of them more or less costly to implement onto a board?
Depends on who you talk to. Some of the nano coatings are effectively more efficient, but I think that process in and of itself is a little bit more expensive.
Okay.
You don't just simply drizzle something on the board. You're actually going through a process, like some kind of vapor distribution onto the board. So.
Okay. We also have a large 48 amp relay here, right? And these CAN bus systems.
Well, actually, one is CAN bus, and one is a RS-485 connector. This one, apparently, Wallbox offers a smart charge or a smart power meter, and so they can connect to this. It's an optional deal, and then if you wanted to network a number of this particular model together, you could use the CAN bus. So this connector is labeled with a proximity and a control pilot signal. And it looks like a way for an undocumented feature of sorts to look at the communication between the vehicle and the wall unit. Depending on whether it's level 1, level 2, snapped in place, the proximity to the vehicle, it will have different voltage levels on it. And so this is an interesting feature. Don't know what its use is. Couldn't find any documentation from Wallbox that indicated what that could possibly be used for.
All right, so we got the high voltage covered. Let's move into the low voltage.
Okay.
We do see some interesting things. So we're going from the flex cable. What's the correct term? This is ribbon cable.
It's ribbon cable, yeah, not flex cable. Flex cable is usually a flat polyamide with copper traces on it, and sometimes some coverlays and things like that on it.
Yeah, I don't see those in computers as much as I used to, so like the nomenclature is not as stressed.
Well, it's interesting, segue, a lot of the old drives, IDEs and things like that, they use this, but then when we went to SATA, it got a lot significantly smaller, and now we're on all of the SSDs, which pretty much connect right up to the board on a socket generally.
Right.
So
we do see some interesting features here. We have the Raspberry Pi board, the super caps, and the wireless Bluetooth connectors. So let's start with whichever one you liked best.
Well, I guess one of the ones that really caught our eye right off the bat was the Raspberry Pi. This one is actually labeled as a Compute Module 3, and it emulates a Model 3 B+ Raspberry Pi. And so it's a full board computer, but it's been streamlined for industrial use. It's using this like SIM type connector, and it's missing the HDMI connectors and all the things that a lot of our Raspberry Pi fans would know about and use. But that was just interesting. It's the first board we've seen like this. SuperCap is great. It's like a battery backup for data and other things. This is the Bluetooth module. This is actually its sole purpose is Bluetooth. It's Bluetooth 5, and then this one here is has a MAC address on it, and apparently it does support Bluetooth, but it seems like having this one here, probably this one is more dedicated towards Wi-Fi. On the back side, we have yet another controller or MCU. There's a TI part back here that is a 32-bit CPU microcontroller.
Okay.
And then the LEDs around the outside edge. Interesting thing about the LEDs is that these are RGB, red, green, blue. So this device, depending on its status, can give you different colors in that ring. Whereas if these were just straight up LEDs, they'd be one color. And they'd have to have multiple of them. And so I think really that's about it. We do have a buck regulator here. So there's a bit of power distribution and regulation. On this board, though, we do see some switches, two of them. One is to switch your RS-485 from terminated to non-terminated. Same thing with your CAN bus, if it's employed, depending on what you have connected to this. We have a actually unpopulated programming plug. There's a reset, and then you can select various levels of current with this device here, this switch. So that's about it. Your usual suspects beyond that.
All right. So the other issue we encountered is charger is not the correct term for this. So my perception is this is like your phone charger. You plug it into the wall, put your phone on it, and then your phone starts charging. But it's not actually a charger, correct?
That is correct. This is really a device to facilitate getting electrical energy from the wall outlet, from the mains, to your vehicle. Once it leaves the wall box and goes into your vehicle, then the onboard charger that is part and parcel with every EV to date does the work of modifying that AC into DC to charge the battery.
Right.
So technically it's not a charger.
But everyone calls it a charger. Even the people that make it are calling it a charger.
Great example is snowmobile. Everybody says, "Oh, a Skidoo," and it's like, no, Skidoo is a brand.
Yes.
So,
and I think that's the big thing. It's their branding. They can call it what they want.
Yeah.
And I don't really have any complaints about calling it a charger, other than it's like not the technical electric vehicle. What's the SE stand
Service
for?
equipment.
Service equipment. That's a mouthful. I'm not going to use it. I don't like acronyms.
Yeah.
And the other one's wall connector, but Tesla's the only one that's using that as it says on the box, wall
branding
connector.
name, right?
Well, it's interesting because Wallbox pretty much says it all. It's a wall box. Tesla's naming is the same way, very inclusive. It kind of says exactly what it's doing. So, but yeah, I know that wall chargers have been pretty widely used, but like you say, that's not accurate.
Antonio, we didn't have a cable length for this one. I know that's been something that...
It's about 4 meters, I believe.
4 meters,
or
okay.
4 of me. So that'd be 2 meters almost. So that's about 24 feet or so.
Okay. So approximately, maybe 25-foot cable. I know that's been something that's been asked from previous videos is some of the cable length measurements. So.
Right.
And then you did a breakdown of the weights for all these components to sort of benchmark against everything we've already covered?
Right. So the electronics, because they have the high voltage and the low voltage separate, it was kind of in the middle of some of the other ones. So it was lighter than the Tesla, which had a lot of the control stuff on it, like the ferrites that were in some of the other ones. It was lighter than the Teardown and heavier than the Teardown and heavier than the Grizzly, which were pretty compact boards.
Right.
The housing was definitely the lightest because it's all composite.
Polycarbonate, right?
And the cable was near the heaviest, with the Grizzly being well, the Grizzly was armored and meant to be outdoors, so they're definitely taking the prize on that one. But overall, this is the second heaviest we've looked at so far.
Okay. Well, I think that probably just about covers everything, gentlemen, unless there's something that we've left uncovered. But
I'm not aware of it.
Okay.
What that might be.
Cool. Well, then we'll be back hopefully with Dave or one of our other electrical team members for our next connector charger teardown, and hopefully we'll be able to keep going into these in this kind of level of detail. So thank you for watching.
Keep it typical.
Have a good day.